Good morning, folks. Welcome to this session. Hopefully, everybody can hear me. So thank you for joining us for this session of how to secure your automation software supply chain. And I'll start this session with a couple of quick questions to the audience, right? So first one is, a quick show of hands, how many of you folks are currently using the private automation hub component of the Ansible Automation Platform in your environment? All right, a few hands, fantastic. So of the three folks who raised your hand, the follow-up question is, are you using, or I guess a show of hands in terms of how many of you are using the content signing and governance component of the private automation hub? None of you are. Okay, so this is great, and this is the perfect audience to learn, right, on this particular feature that's available in the private automation hub, and we want to also talk about why this particular component is important. So I'll start with a quick anecdote about my own experience. You know, so before joining Red Hat, for the longest time, I was a network engineer working for a large corporation, and one of the things that I used to be annoyed about these corporate security emails where there was all these phishing training emails from security and compliance teams, right? They would say, hey, you know, don't click on unauthorized links. You might cause a security incident in your environment. And occasionally they would send out these emails testing us, right, whether we would click on these links. And if we, you know, it looked like a suspicious email, if somebody clicked on it, or we'd get slapped on the hands. You know, so when I think back on it, that was actually a great campaign, you know, kind of instilling good security hygiene in people who work for the organization to make sure that you don't click on bad emails accidentally and cause a security incident. However, at the same time, there was no mechanism, there were no tools, there were no guide rails on, you know, how people were downloading software on their laptop to do their jobs, right? So I, as a network engineer, was very interested in learning how to automate my networks. I did not have any software background. I had no idea of, you know, secure development practices. I had no idea how to build good quality software. But I wanted to solve my problems, right? And the way I was solving my problems was go and search on Google, right? I'd go and search on Google, okay, how do I do this? And oftentimes there would be like a sample script, or, you know, there would be like a Python code or something, and I would try to run it from my laptop, and it'll say, okay, it has a dependency on this library. I would just download and install the library on my laptop, and away we go, right? Little did I know that I was introducing a potential, you know, security gap, I guess, right, in my environment by downloading these libraries and installing them and operating them. So in this session, we're going to learn about, you know, how organizations honestly are still doing that, right? It's not, so this was like in 2013, and hopefully I've learned from that, but I see many of my customers in lots of environments still having those kind of practices, right? So we're going to talk about the component features of the Ansible Automation Platform that you as Ansible Automation, you know, administrators, right, platform administrators can avoid. So my name is Ajay Chinampara, and I'm the automation strategy leader for the North American public sector within Red Hat. And with me is Anshul. Introduce himself.
Hi everyone, I am Anshul Behel, and I am a Principal Technical Marketing Manager for Ansible. And so yeah, anything that's related to blogs on Ansible, documentation, even labs, you'll probably see my name there. So I work with a lot of components of the platform, and here today I'm going to explain how these features of signing works and how you can secure your automation supply chain using the features and components in Ansible Automation Platform. Yeah.
Thanks, Anshul. So let's start with what does the software supply chain look like, right? So this reference diagram comes to us from the National Counterintelligence and Security Center team, right? So according to them, right, you can see examples of software supply chain attacks that have been happening over the past few years, and the fact that these attacks can happen at all phases of the development process. All right, so let's take a step back and think about, why are attackers targeting the software supply chain, and why is it now, right? Interestingly enough, the study shows that the reason why attackers are going after the software supply chain is because most organizations have started improving their security posture when it comes to, traditional data center, right? So adopting good practices like defense in depth, having IDS, IPS tools, having firewalls, right? Doing all the patching, right? All the normal security hygiene things that folks are doing have led to the bad actors targeting other places where they can insert malicious code. And the software supply chain seems to be ripe for it, right? And interestingly enough, because of how open source software works, given that it's open and anybody can contribute, anybody can view and read that code, that seems to be another specific target for attacks as well. Now, I want to touch upon the impact of just one of them, right? We'll just talk, I put the financial impact of a few of them here, but I want to talk a little bit more than just the financial impact, right? So I want to just touch upon the NotPetya attack real quick, right? So how many of you are familiar or had to deal with the NotPetya attack by any chance? I see one hand there. So just to give you a little bit of a story about the origin of that particular attack, right? So just like how we use TurboTax here, right, to file our taxes, I guess the most popular tax software in Ukraine was this company called Medoc. And it's a small software firm, family-run software firm, and their update process, right? The way they sent patches to their customers was compromised allegedly by the Russian military forces, right? And they inserted this malicious piece of code in the next patch that the Medoc software was delivering to their customers, and that ended up being distributed widely across computers. It spread, it infected everybody pretty much, and the country that was most impacted was Ukraine, right? But I think the impact was really global, right? Because when you think about what the result was, the Chernobyl radiation monitors went offline, right? The metro transport systems went offline. The national bank went offline. Energy companies went offline. Right? It was significant. So more than even just the financial impact of something like a NotPetya attack, right, and any impact to your software supply chain, it can pretty much bring down, critical infrastructure that citizens need. And the other scary part was that, that while I was researching for this particular topic, that I found was that 32% of organizations implicitly trust open source software. Now just think about that, right? So let's take Ansible as an example, because we're talking about, we are at a Red Hat conference, and I love Ansible, so let's talk about Ansible, right? So I was talking to a couple of folks from a university yesterday. I don't remember the name of the university, but they serve around 72,000 or 74,000 students within their campus, right? Their network team manages 2,000 network devices using open source Ansible. Right? It's a great story, but that's also scary in the sense that that network team does not know how to make sure that the code that they're getting from upstream Ansible repositories are clean, they're quality tested, they're secure, they're supportable, right? So they're just taking a risk in terms of managing their 2,000 nodes. So that's an example of a scary story there. Good thing about this information is that many CIOs, at least 82% of them, say that they know that their organizations are vulnerable, right? So that's I think, a step in the positive direction. And lastly, the fact remains that, from 2021, if you look at the data, these attacks are growing, right? Attacks to the software supply chain are definitely growing. So I had these bullet points in here basically to kind of reinforce that, hey, from a urgency standpoint, we have to, as an organization, as someone who is delivering whatever software that you're delivering, specifically in terms of automation in this particular context, we need to think about how are we trusting, right? What is that trusted chain of automation content that our users are using within our environment? So if you look at software consumptions models in general, right, there are two types of trust at a very, very high level, in my opinion, right? So there is the implicit trust when you buy some closed software from a vendor, you have some sort of a central purchasing or sourcing team or purchasing team that negotiates the prices, defines the SLA, and makes that central source of software available to the rest of the organization, and you tell the rest of the organization that this is the only allowed software within your company that you're allowed to use and consume. That's one model. The other model is pretty much Wild West, right? So there's like, I don't know, million plus open source projects out there, plus a whole bunch of scripts that you can probably get ChatGPT or Stack Overflow to generate for you, and you just implicitly trust them, right? If you are not a software developer, if you are not adhering to secure software development life cycles, you're just going to consume this. You're going to download it like an app. You've been used to downloading an app in your iPhone. You would download a bunch of code. You would download a collection from Ansible, Galaxy, let's say, and you would use it from your laptops without really thinking about, how do you know that this code is secure? So in order to kind of mitigate and bring in hygiene for software consumption within organizations, now the government is trying to step in, right? So there's been executive orders from both previous presidents. There's been official NIST recommendations on how you should build secure software. And there are, especially for state, local agencies and for federal agencies, there are key deadlines for which they must, they must start producing things like software bill of material. How many of you folks have to deal with SBOMs here? All right, I see one hand. Yeah, so all these things become a concern because now you have to have some way to show, right, that you are introducing governance to your process. All right, and now let's think about, when you look at the Ansible ecosystem, right? So, okay, so you have adopted Ansible in an organization, you want to bring about automation best practices, but just like any other piece of software, Ansible has its own development life cycle as well, right? Whether you're a playbook creator or creating collections or modules or whatever it is, there are different phases through which you will be writing this automation code. And each of those phases can potentially be an attack vector. Now, the feature that we're going to talk about in a lot of detail in this session is going to focus on introducing governance and control, right? Being able to do content signing for the content you develop. So it's going to focus really on this third bullet in the secure software development framework, which is produce well-secured software. Okay. All right. So when you look at the Ansible Automation Platform at a high level, right, there are two places where you can introduce governance and security and control. Right? The first one is the Automation Hub. The Automation Hub is the SaaS-based source of truth, central repository that provides all the certified, supported, quality-tested content that Red Hat curates and makes available for our customers, right? So this is obviously a subset of the hundreds of thousands of collections that are out there in the wild that Red Hat curates, Red Hat makes available to our customers along with our partners, right? So for instance, Azure and AWS write their own collections. We secure, we make that available to our customers. So that's one point where you get signed certified content. The other one is the private automation hub, right? Which is why I started off this talk with asking you about how many of you use the private automation hub. So the Private Automation Hub is an on-premises installation or version of that Automation Hub. And the Private Automation Hub serves as a content repository for all your automation artifacts, right? So this is going to be that single source of truth that you can, as a platform administrator, you can provide to Ansible developers inside your organization. If somebody's writing a playbook, if I'm a network engineer who doesn't know anything about secure software development lifecycles, right, and I go and talk to my Ansible platform administrator and say, hey, I need the Cisco collection in order to write my playbooks, they're going to be able to point me to that Private Automation Hub as the source of truth so that I'm not downloading something randomly from the internet, right? So it gives you the ability to provide that central source of truth for curated content within your organization. Now, I'm going to sum it up before handing over to Anshul here, right? So automation, right, has existed since computers have existed. But what's happening in the industry, what I'm seeing in the industry especially, is that automation is being formalized. It's becoming a pillar in the IT organization. And I see it not only in things like job requirements. If you just do a search for automation type titles, you can see that that's an emerging requirement for traditional roles, and there are titles with automation engineer, automation director, things like that I'm seeing in the industry, right? If you look at analyst predictions, you can see, according to Gartner, by 2025, 70% of organizations will implement structured automation, right? Structured infrastructure automation. So what's structured infrastructure automation? So basically, what analysts are predicting is that there's going to be, an enterprise-wide framework. It's not going to be silos of automation. It's not going to be people writing their own scripts. It's not going to be people writing code to make their lives easier, but it's going to be enterprise-wide structured frameworks for automation, right? So all this to say that automation is becoming very, very important in terms of how people are managing their infrastructure. And I don't know if anybody caught the Dell CTO, I believe, who was talking about, infrastructure teams are no longer cost centers, right? They're expected to innovate and keep pace with the business, right? So automation is going to be key to helping those infrastructures get there. And once that becomes an important business component, it is extremely important to make sure that that component is secure. And to talk in depth about that is Anshul here. Thank you.
So yeah, thank you, Ajay. Thank you for the introduction to the topic. I, on the other hand, will probably talk about in detail on how these features work in Ansible Automation Platform. And we'll talk about what are, I think Ajay also showed the attack vectors. We'll talk about these attack vectors and see how Ansible is securing those. Okay, so can I get a show of hands on who is using Ansible Automation Platform 2 right now? Who all has upgraded to Ansible Automation Platform 2? Okay, so yeah, so Ansible Automation Platform 2.2 brought new chain of custody features. What these chain of custody features mean? Ajay talked about how are you getting your collections for your automation. You can either get it from Ansible Galaxy, that's the community content. You can also get it from public Automation Hub, which is at console.redhat.com, which holds the certified content. Now, all the content on the public Automation Hub is now signed through the Ansible's partner engineering team and the Red Hat's product security team. What that means is any collections that you basically download from Red Hat to automate your workflows in your organization are signed, meaning that they have a chain of custody from Red Hat showing that the owner of this content is Red Hat, and you can build that chain of custody in your organization saying, okay, I can trust this content because it's coming from Red Hat. So that was the first point, Automation Hub and the Red Hat Ansible certified content. The public automation hub, all the collections there are now signed as well, apart from being certified. So it now holds certified and signed content. Second point being private automation hub. So like we talked about, we want private automation hub to be the source of truth for your organization for all automation content, be it collections, be it execution environments. So the idea that if there are collections in your private automation hub and if there are execution environments in your private automation hub, we want to give you features so that you can build that chain of custody. And those features are now available in private automation hub. Basically, you can sign your collections and you can sign your execution environments in private automation hub. So just talking about the vectors here, what are the attack vectors? Basically, the content that you're getting for automation, or basically you want to build Ansible automation on, where is it coming from? We are just trying to secure all the sources for the customers. On the diagram, you'll see the check marks where we have the signing capabilities. Basically, the first one being public automation hub, console.redhat.com, like I talked about. Second one being private automation hub. And the third one, the A sign inside the black box, that's the logo for automation controller. There are signing features or verification features available in automation controller now when you pull your projects. So that's also where we have built the chain of custody. So I'll talk about that in a bit detail. And on the right-hand side, these are just the use cases of automation. So you can basically, you can do network automation, security automation, cloud automation through Ansible, but we want to make sure that any sources of those automation are secured, and that's the idea here. Just a quick look on how the public automation hub looks like now. If you have used public automation hub, you would have seen this UI, but now on the right-hand side, you'll also see a kind of a stamp called these collections are now signed. Basically, when we work with partners to certify their collections, as soon as a partner uploads their collection, those collections are also signed. This means that we are building that chain of custody from Red Hat, that the source of these collections is Red Hat, and these are not coming from somewhere else. So basically, that's the meaning of this. Just securing one source here right now. We'll talk about others. Okay, now let's talk about signing in private automation hub. Okay, I want you to focus on, let's see, on this side. This talks about the sources of automation in your organization, right? So let's talk about the sources of organization. On the top, you'll see Ansible ecosystem. I talk about Ansible content can come from either the supported content, which is the public automation hub. We have secured that using by signing the collection. The second one can be community content. So how do you trust the community content? You cannot, because it's open source content. Ajay talked about that. The idea that you can pull open source or community content in your organization, that is an attack vector, and that's where the signing capabilities of private automation hub comes into picture, because any collection that you pull into the private automation hub, you have the capability to sign them now, and that's how the community content can become can have a chain of custody or can become a bit more secure. So because you will, in your organization, you can make sure that I have pulled this as an administrator, you know that I have pulled this content in my organization and I have signed it. So any developer who's using this content will know, okay, this is coming from inside my organization and I can verify this. That's the signing capability of private automation hub. Other part on the second side is you can have enterprise SCM where you can hold your own collections that you're building in-house as a customer. And then you can have your playbooks that you're running to do production workloads or production workflows. So how do you secure them? For the content collections, again, we want private automation hub to be your source of truth for all content. And it has the capability to sign collections now. The idea now being any collections that get uploaded to private automation hub can be signed. So that is how we build the chain of custody. Talking about the playbooks part, playbooks comes into picture when you're running them as job templates in automation controller, or formerly known as Ansible Tower, and that's where we'll talk about the project verification piece in the later slides. Yeah, so just understand, if you're taking one thing from this basically presentation, the idea that you need to understand where content is coming into your organization. From our, at least, these are the 4 sources that we have accumulated, and we want to make sure we are securing each and every one of those. Private Automation Hub signing secures all the collections as well as the execution environments. And then you have features in Automation Controller to basically sign your playbooks. So that's how we are securing your automation supply chain. Again, on the right-hand side, you'll see some features of Private Automation Hub. It has role-based access control, it has Galaxy Importer, and now it has a feature of content signing. I have added some screenshot on how it looks like on the UI. Whenever you upload a collection to Automation Hub, you'll now see a sign and approve button, which means that when you upload a collection, it goes into approval, and then you, instead of just approving it to be published, you're also signing it now. And on the right-hand side, like it showed in the public Automation Hub, it can also show on the Private Automation Hub that a collection is signed. So same features, again, it's the public Automation Hub, the Private Automation Hub component is kind of a replica of the public Automation Hub. The public one is maintained by Red Hat. Private one, a customer maintains on their side, and this is how it shows how your collection will be signed. Okay, next one. Okay, let's talk about how do you sign collections on Private Automation Hub. Has anyone worked with the setup.sh file to install Ansible Tower or an automation controller? Yeah? So, okay. So what you do, how do you install Ansible Tower? So historically, we have had this script called setup.sh that comes with the package. And you provide an inventory file where you want to deploy an automation controller or Ansible Tower, basically telling it, okay, on this host, I want to deploy Ansible Tower or automation controller. It can also deploy Private Automation Hub for you. And the inventory script has some variables. So now let's quickly look at the variables, the new variables that are introduced for signing. So the new variables that were used for signing is, okay, so first of all, this signing is GPG based. And that's that's a globally accepted standard for signing software artifacts. So that's why we are also depending on GPG. So the idea here is you create a GPG key pair, basically a public key and a private key. You have a signing script that we give you an example of that you can also create your own, but then you have to make sure that you know the input and output variables. Once you have a signing script and a private key, you give it to the variables in the inventory file. So check the last two variables. These are Automation Hub collection signing service key. That is your private key to sign artifacts on the Private Automation Hub. So whenever you upload a collection, this key will be used to sign that collection. Then there is a Automation Hub collection signing service script. This script will act as a signing service to basically use the private key as an input to sign your collection. And then whenever you deploy your Private Automation Hub with all these variables, you will have a Private Automation Hub that has the ability to sign content, basically the collections and execution environments. And that's what this shows. You give a GPG key pair, you give a signing script to the inventory, and then you run the setup.sh. You'll have a Private Automation Hub that will be signing enabled. Okay, let's talk about the collection signing service. I talked about this first part. Using the signing script as well as the GPG private key, you get a signing service that's enabled on Private Automation Hub. What it does is whenever you upload a collection on Private Automation Hub, this is how the collection tarball looks like. All the collections have a manifest file that basically tells what this collection holds. And what this signing service does is it signs the manifest file and stores the signature in the database of Private Automation Hub. That's the basic idea of how signing is working on Private Automation Hub. And whenever you try to download a collection from Private Automation Hub using the Ansible Galaxy CLI, and you provide the public key, because we use private key to sign content, you use the public key to basically verify content. As soon as you give it a public key, the Ansible Galaxy CLI knows I need to verify this collection as well. It will then verify the collection using that public key. That's stuck, yeah. Okay, let's talk about automation execution environment signing. We talked about one thing now, the collection signing. Now, what else you can upload or what else you can host on Private Automation Hub? That's the execution environments. So Private Automation Hub also has the ability to sign execution environments now. The service, again, looks very similar to how you sign collections. The only difference here is we were storing the signatures of the collection inside the database. Here, we store the signature with the container. Execution environments are containers, so with container images, we are storing the signature of execution environments in those container images itself. So that's the only difference, but the idea stays the same. We want to sign the collections, we want to sign the execution environment. This is how we are doing it. There's the third thing. Now, the third thing here is you can, when you build your execution environments, you tell the execution environment to pull collections. So when you're building execution environment, you can also provide that public key to Ansible Builder to build execution environments. What that will do is that Ansible Builder will use that public key to verify whatever collections it's building into the execution environment. So that's the third vector here. Okay, so you create an execution environment with collections. You can use that to verify the collection as well, because those are coming from Private Automation Hub and those are signed. Then you have the execution environment signing. Then you have the collection signing. We are trying to cover all the vectors here. Okay. Now let's talk about the last and final vector, which is the project signing and verification in Automation Controller. So that's the final thing. Now you have your playbooks that you want to run in your organization as job templates. Those playbooks, you want to make sure that you have committed those playbooks to a repository. You want to make sure that no one has tampered those playbooks, because you want probably want those playbooks to run in your production. And if there is any unwanted code that's going to run in your production, you probably want to secure that. And that's where the project signing and verification comes in, because we are trying to sign the playbooks that are in your source control repositories. Okay. So project signing in 6 steps here. Again, this is also GPG based. So first thing again is to create a GPG key pair. Second one is basically create an ASC file. Think of the ASC file, it is the ASCII armored file, as the public key from that key pair. So we we basically export the public key from that GPG key pair. Third one is create a manifest in your Git project. Okay, so I have a Git project that holds 10 of my playbooks. I want to make sure that I am creating you want to make sure that you're creating a manifest file that tells Ansible Sign, which is another tool, which is the 4th step here. Ansible Sign is a new utility that was created to sign projects specifically. So we want to create a manifest file that tells Ansible Sign what files I need to sign in this repository. So you have a repository with 10 playbooks. We want to sign all of them. Just tell Ansible Sign, or to create a manifest file that tells Ansible Sign, okay, sign all of these. These are also well documented in blogs and labs and documentation. I'm just giving you a rough idea on how this works. The 4th one is then use Ansible Sign to sign your project. Basically, Ansible Sign will look at your manifest file and try to sign all the files in your project. Once you have signed everything, you can push the signatures and those files to your Git repository. And then once you sync the project into Automation Controller or Ansible Tower, that is where you add your public key, and that is where a verification step will also happen, because now it knows that the project is signed and then it needs to verify it. The sync will try to verify the project as well, verify the project as well as checksum. It doesn't work in one. Okay. How it works? Again, I'm just giving a bit more detail here. Take a look at this command, Ansible sign project, GPG sign, and then path to project. Path to project means your local repository that you want to push to your Git or GitLab or SVN, anything. So basically, using the manifest file, if you run this command, it creates a checksum file as well as a signature file. Why do we need 2 files? A checksum file is to make sure that the files that exist in the project are not changed. A signature file is to check that the files that are in the project, there's no addition or deletion of the files. So basically, we are checking if the files are tempered. We are also checking if there are extra files added or deleted from your repo. And then you sync that. as a playbook developer, basically you push that to your SCM repo. I talked about all these steps. Then you do a project sync. The project sync will verify the signature and recalculate the checksums, checking if the files are not tampered with. If the validation fails, you cannot launch the job template. If the validation is successful, you'll be able to launch the job template. Again, this is an optional step, but if you provide automation controller Ansible Tower with the public key, it will try to do the verification and then fail or pass based on what's in your project, or if the signatures are valid or the checksums are valid or not. How it looks now. So how it looks on the Ansible Tower or automation controller. Take a look at this one. It says content signature validation credential. This is a GPG credential that you add in Ansible Tower. I've named it Ansible sign for this screenshot, but yeah, a GPG key was added, and then in the new project, when you create a new project where you give it your Git URL, you also give this credential. Based on this credential, it will try to say, verify and validate if the project is valid or not. And then when the project sync job runs, that you probably know about, whenever you save the project, it runs a project sync template. These are the new steps. You see, these are verifying the content of GPG signature, and then it's verifying the checksum manifest. So basically, verification is happening on the fly. There are resources available. There are self-paced labs that are publicly available where you can see how signing happens in Private Automation Hub, how signing happens in project signing in Automation Controller. And there are blogs available. How do you digitally sign your collections? How does the project signing and verification works? And then there's the Ansible documentation that also talks about this. And then, yeah, let's move to the Q&A, but then the whole intention of this topic was, since this is a new feature, we also want to gather feedback from customers. So try this out, try the resources, and make sure the slides are also available to you. But yeah, once you try the resources, just give us feedback also, if you like this feature, if it's actually helping you securing your automation supply chain. And now we can jump to the Q&A.
And before we go in also, I just wanted to reinforce that, so today when you look at automation and infrastructure automation as a whole across the industry, right? There is no other product or platform out there that is providing you any kind of capability to do this kind of governance and control, right? To be able to kind of give you opinionated ways of helping your organization, right? Write good quality, secure Ansible code, right? And from a roadmap perspective, right? What I can think of is that this is only going to improve from an Ansible standpoint. We're kind of like setting the stage and we're setting the standards on how automation products should be used and consumed within organizations. And you can see with the announcement of Lightspeed and all these things with the whole Ansible ecosystem, all these things are going to be even better. So hopefully, right, if you've not been using this feature or if you've not been using Private Automation Hub, this session helps you understand what capabilities are available as part of the platform and how you can use it, right? And the resources provided here should give you an option to get some hands-on through interactive labs, allowing you to experience this particular feature before trying it out in your production environment. So that's the only thing I wanted to add here, and we can go on to Q&A. I noticed that you had a question, yeah? Can you use, sorry, what? Oh, can you use Nexus as a private automation hub? So Nexus is a container platform, a container repository solution, right? What exactly is Nexus? Got it. So from a platform standpoint, right, the only supported solution is going to be the Private Automation Hub. It might work with Nexus, right? But the thing is that if you run into some sort of integration issues, or if there's a new feature that's pushed out that requires Private Automation Hub, those are the places where I see challenges, right? So I've seen customers, especially in the telco space, right, where they use something like any standardized container repository for their execution environments, right? They probably have container scanning and established security practices for containers, and they just want to leverage that. And it works fine, right? As long as you know the limitations of where support ends and what's critical for SLAs, as you as a automation platform, as a service provider for your organization, right? As long as you know what the limitations are and what cannot be done, that's going to be the trade-off there.
Yeah, also Private Automation Hub is a feature of Ansible Automation Platform. So if you're trying to use something else like a different container registry like Nexus, you can use that with Automation Controller. But these features are part of Private Automation Hub only. We are not sure how Nexus will work with signing or the other. Are they able to secure your supply chain or not? Do they have these features inbuilt? But then we want to make sure we are giving you enough features to secure your supply chain. Yeah. Yeah.
So we have a separate private automation hub for our development environment and our production environment. Could we do code signing in our development environment as part of our promotion process and have the one in our production environment only allow to pull code from the private and the dev environment?
Yeah.
So we can confirm that it's only source code.
Yeah, because when you have two private automation hub, they can work as repositories for each other. The point being the dev one can work as a repository for the production one. So basically, when you pull the collections from the development one as a repository, you can do that, but then you have the extra capability of signing on the production one itself. And then I didn't talk about, you can change the signatures as well. So basically, if you signed it in your development, if you signed it in your production, you can actually verify both of those signatures when you download the collection from Ansible Galaxy CLI. You can also tell the Galaxy CLI if you want to validate one or multiple signatures, basically.
Yeah, that way you can kind of enforce that, hey, a development quality collection is not hitting production, right?
Yeah, exactly. And then you can actually you are building that chain of custody, like from dev to prod, you are also verifying both of those signature, so that, you can do that,
Great question. And any other questions, comments? Yep.
Can I use those signing tools in a CI/CD pipeline? So you showed the GUI and stuff, but I maybe want to do in the CI/CD pipeline my security checks and then sign to
Yeah, the signing happens for the collection in the private automation hub, but the verification happens through the Ansible Galaxy CLI tool, so that you can integrate into your CI pipeline. So signing will happen only on private automation hub because that is where you're uploading the collections and that is where the signing happens. But the verification, because you're pulling the collections somewhere, you want to check that, the verification can be a part of CI process and can be done through the Ansible Galaxy CLI. Yeah. For the project one, you use Ansible Sign to sign your projects. So the signing in the private automation hub happens in the UI. The signing for your projects, because it's a Git repository, happens through CLI. That you can use as a CLI in your CI process to basically sign your projects as part of your process, basically. Ansible Sign tool and Ansible Galaxy can be used to sign as well as verify the projects. Yeah.
So because when you think about the CI/CD process for different components of content, right? So you have your playbooks, right, which is in your project. You have your collections, which are built as an artifact, which probably has a different, CI/CD process compared to the process that you use for developing your playbooks, maybe, right? And then your execution environments, have their own CI/CD process, right? So because you define your container file, right, through Ansible Builder or whatnot, and that builds out your container. So depending on that type of content that you probably have different CI/CD processes. What I'm trying to get to, right? And each of them, so the signing part, it makes sense for certain piece of that to be done at the GUI because now, as part of when you're building a collection, right, or consuming the collection as a user, you want to build that playbook development process to make sure that, okay, I'm using a verified collection that has to be automated. That should be part of your CI/CD process, right? But as a platform administrator, you probably want to have some mechanism to make sure that the collection that you are making available for your organization is signed, and that part is through the GUI.
Yeah, through the GUI, but then I showed you some options of the inventory file. There is an sign on upload option as well. So basically, you don't need to click anything to sign. This was the option that I showed you was it requires approval, but you can also set it up that as soon as you upload a collection, it will be signed because the signing service is enabled on the Private Automation Hub. Yeah.
Is there a setting to require the use of a key as part of the creation of a project?
Is there a setting to require the use of a key for setting up a project?
In Ansible Automation Controller, basically. Yeah, that's the option that I showed you. If you set that key, basically.
But can you, I saw where it's an option.
Yeah.
Can you require?
Force it, yeah, can you require
Oh,
it?
it doesn't force it yet. So basically, it's an optional setting right now.
Okay.
Yeah, so it doesn't force you, but then again, since you are the platform administrator, and you can basically lock the access to automation controllers, and if you are the one who's syncing projects, you can make sure you're also checking them. Yeah, if you're giving users access to sync their own projects, then it might be a problem. But if you're doing it yourself for the organization, then you can do it at your level, basically. Yeah.
So our design process is that our engineers, our infrastructure engineers build the content and development, they test it, they promote it. When it gets approved and promoted and available in production, they create the project to do the syncing because they are the ones familiar with it.
Yeah.
They create the template, the jobs to go with
Yeah.
it.
Yeah.
So I just want to make sure that if we're going to go down this route of securing it,
Yeah.
that they don't bypass it.
Yeah, fair enough. And I don't know, I mean, like the way I can think of it is if individual teams are responsible for doing that, right? One way you as a platform administrator could not enforce it, but at least keep checking it is by using the controller collections. Have you used the Ansible controller collection? Yeah, so the controller collection, pretty much you can use that API interface. Basically, you're running a playbook maybe on a scheduled basis to check whether all the projects that are in your platform are using that option, right? And if they're not, maybe you can send them like an email saying, hey, turn this on or something like that, right? But at this point, if you control the project, it's an option that you can turn on or off. Yep, great question. Yep. Yeah. Hopefully this was instructive and informational. And if you've not been using it, hopefully you'll start using this. We'd be happy to hear any feedback and yeah.
Yeah, we would love some feedback on this because these are new features and not a lot of customers are using them. But yeah, we want them to use it because like it's an important factor to consider to secure your supply chain, right? So yeah. Cool. Thank you everyone.